Today's headlines turn to a pressing development that could reshape how the United States prepares for hurricane season. The National Oceanic and Atmospheric Administration, or NOAA, has permanently decommissioned one of its most critical hurricane monitoring tools, the Special Sensor Microwave Imager Sounder, or SSMIS. This advanced satellite instrument, which for nearly 2 decades provided meteorologists with real-time data on storm development over the open ocean, is now offline. Its retirement comes at a critical time, just as the 2025 Atlantic hurricane season enters its peak, with forecasts already warning of heightened activity fueled by unusually warm sea surface temperatures. SSMIS had been a cornerstone of hurricane prediction. Unlike visible satellite imagery, which simply shows cloud formation, this sensor captured microwave radiation emitted from Earth's surface, allowing it to see through clouds and measure essential storm features like wind speed, rainfall intensity, and atmospheric moisture content, especially vital in remote ocean regions where no weather buoys or radar exist. For years, SSMIS played a behind-the-scenes but irreplaceable role in improving forecast accuracy. It helps scientists detect the early stages of cyclogenesis, the moment when a tropical disturbance begins forming into a full-fledged storm. More importantly, it offered consistent, high-resolution updates on storm structure and evolution. Without this data, forecasters now face significant blind spots, especially during the early formation phases of tropical systems. According to NOAA officials, the SSMIS instrument had reached the end of its technical lifespan, and efforts to maintain or replace it became unsustainable. The cost of operating the satellite exceeded $30 million annually, and internal assessments found it was no longer possible to ensure the accuracy of its readings due to calibration drift and aging hardware. Though NOAA is already planning a replacement as part of its next-generation satellite program, that system is not expected to launch until at least 2028, meaning forecasters could face a multi-year gap in observational capacity during one of the most volatile periods for Atlantic storm activity in recent history. This decision has sparked strong reactions across the meteorological and emergency preparedness communities. Several prominent forecasters and research scientists have expressed concern that retiring SSMIS without a ready replacement leaves the country and the broader Atlantic basin vulnerable. The National Hurricane Center has stated that while it will continue to rely on other tools, such as aircraft reconnaissance and infrared satellite data, none of these provide the same comprehensive perspective that SSMIS offered. This shortfall could mean less accurate track and intensity forecasts, particularly in the crucial 72-hour window before landfall, which emergency managers use to make evacuation and resource deployment decisions. In short, the lack of microwave data could reduce the lead time and precision with which authorities warn communities in a storm's path. President Donald J. Trump, in his second term, addressed the issue briefly during a press conference this morning. "We've built the best weather and emergency response systems in the world, but now we've got to act fast to make sure they stay the best. NOAA's been given the green light to expedite the new satellite program. We don't want anyone left in the dark when the next hurricane comes," he stated. The president also indicated that he would support increased funding in the upcoming emergency preparedness budget to fill the monitoring gap with expanded drone and balloon-based observation networks, although specifics were not provided. Meanwhile, the private sector is stepping into the conversation. Several commercial satellite companies have offered to provide substitute data streams, albeit at a premium. While these sources may help mitigate some of the gaps, they're not integrated into NOAA's operational forecasting models yet. That integration could take months, if not years, due to the need for rigorous calibration and validation. Emergency managers are particularly worried about underserved coastal areas, especially in parts of the Gulf Coast and Caribbean, where small islands and vulnerable populations rely heavily on early warnings to evacuate safely. Without microwave soundings from space, the concern is that smaller but still dangerous tropical storms could be underforecasted, catching communities off guard. This development also raises broader questions about infrastructure investment and climate resilience. As climate change accelerates the frequency and intensity of hurricanes, the tools used to predict these storms become even more critical. In recent years, record-breaking hurricanes have devastated communities from Louisiana to Puerto Rico, costing hundreds of billions of dollars and claiming thousands of lives. Every hour of advance notice counts. Experts warn that the loss of SSMIS is a setback not just for weather forecasting, but for national security and disaster mitigation as a whole. In response, advocacy groups and bipartisan coalitions in Congress are urging an emergency review of America's satellite weather architecture. A resolution introduced this week calls for NOAA and NASA to accelerate the development of microwave sensing alternatives, with proposals including rapid deploy CubeSats, partnerships with allied space agencies, and interim funding for enhanced aircraft surveillance missions in storm-prone zones. The resolution is gaining traction, with support from both Republican and Democratic lawmakers representing coastal districts, particularly in Florida, the Carolinas, and along the Gulf. Looking ahead, the 2025 hurricane season is already proving active, with 3 named storms forming before July. Forecasters are now relying more heavily on older instruments and predictive modeling that may not fully reflect real-time changes in ocean and atmospheric conditions. This means forecasts could become more uncertain, especially when storms intensify rapidly, a phenomenon that's becoming increasingly common due to warming ocean temperatures. Communities are urged to remain extra vigilant this season, not only because of the storm risk itself, but also because the tools used to predict that risk are temporarily less capable. To wrap up, the retirement of SSMIS marks a pivotal moment in U.S. hurricane forecasting. While its decommissioning was not unexpected, the timing, right at the start of a potentially severe storm season, has drawn sharp criticism and ignited urgent conversations about preparedness, resilience, and scientific investment. The loss of this data doesn't just impact meteorologists. It affects every person living along the coast, every emergency planner, and every first responder preparing for what may lie ahead. We'll continue tracking developments in NOAA's replacement plans, federal funding discussions, and the evolving outlook for the 2025 storm season. In the meantime, stay safe, stay alert, and don't wait for the last minute to prepare. With one fewer eye in the sky, the stakes have never been higher.